The National Electrical Code, Section 250.52, states that a metal underground water pipe in direct contact with the earth for 10 feet or more shall be used as the grounding electrode. Section 250.54 states that if the resistance of the primary grounding electrode is greater than 25 ohms, a supplementary grounding electrode shall be added. The situation involves the installation of a 200 amp service in a new single-family dwelling. An underground copper water pipe was used as the grounding electrode, according to Section 250.52, and an 8-foot ground rod was installed as a supplementary grounding electrode, according to Section 250.54. The electrical inspector violated the service, stating that an additional ground rod was required or proof of a test that the 25 ohms of resistance or less are met, according to Section 250.56. The understanding was that if an underground water piping was used as a primary grounding electrode and augmented that with a ground rod, the resistance requirements for the rod did not have to be met. However, that understanding is incorrect. According to Section 250.54, if the primary grounding electrode is an underground water pipe, the resistance requirements for the supplementary grounding electrode do not apply. To resolve this, documentation should be provided to the inspector that the underground water pipe meets the requirements of Section 250.52. This can include a statement from the water utility confirming that the pipe is copper and is continuously buried for at least 10 feet, and measurements of the resistance between the water pipe and the grounding electrode system. If the inspector is still not satisfied, it may be necessary to install an additional supplementary grounding electrode. However, based on the code requirements, this should not be necessary. In summary, the installation is correct and the inspector's violation is incorrect. The inspector should be provided with the necessary documentation to prove that the installation complies with the code. Grounding electrodes are used to provide a low impedance path for fault current to return to the source. This helps to protect people and equipment from electrical shock. The grounding electrode system typically consists of one or more grounding electrodes that are bonded together. Grounding electrodes can be made of various materials, including copper, steel, and concrete encased electrodes. The type of grounding electrode that is used depends on the soil conditions and the local electrical code. The National Electrical Code, or NEC, provides specific requirements for grounding electrode systems. These requirements are designed to ensure that the grounding electrode system is effective and safe. The NEC requires that all grounding electrodes be bonded together to form a single grounding electrode system. This bonding ensures that all parts of the grounding electrode system are at the same potential. The NEC also requires that the grounding electrode system be connected to the neutral conductor of the electrical system. This connection provides a path for fault current to return to the source. The NEC specifies the minimum size of the grounding electrode conductor. The size of the grounding electrode conductor depends on the size of the service entrance conductors. The NEC also specifies the minimum size of the bonding jumpers that are used to connect the grounding electrodes together. The size of the bonding jumpers depends on the size of the grounding electrode conductors. Grounding electrode systems should be inspected regularly to ensure that they are in good condition. The grounding electrode system should be inspected for corrosion, damage, and loose connections. Any problems with the grounding electrode system should be repaired immediately. The purpose of supplementary grounding electrodes is to lower the overall resistance to ground of the grounding system. A lower resistance to ground helps to ensure that fault currents will flow quickly and safely back to the source, tripping the circuit breaker or fuse and preventing electrical shock. In situations where the soil has high resistance, or where the primary grounding electrode does not meet the required resistance value of 25 ohms or less, a supplementary grounding electrode is required. This supplementary electrode is installed in addition to the primary electrode, such as a metal underground water pipe, to improve the overall grounding system performance. There are several types of supplementary grounding electrodes that can be used, including ground rods, ground plates, and concrete encased electrodes. Ground rods are the most common type of supplementary grounding electrode. They are typically made of copper or copper-clad steel and are driven into the ground. Ground plates are flat metal plates that are buried in the ground. Concrete encased electrodes, also known as UFA grounds, are made of a bare copper conductor that is encased in concrete. The selection of the appropriate type of supplementary grounding electrode depends on the soil conditions and the local electrical code requirements. It is important to consult with a qualified electrician to determine the best type of supplementary grounding electrode for a particular application. The installation of supplementary grounding electrodes should be done in accordance with the NEC and local electrical codes. The electrodes should be installed in a location where they will be in contact with the earth and where they will not be damaged. The electrodes should be bonded together into the primary grounding electrode to form a complete grounding system. Regular inspection and testing of the grounding system is important to ensure that it is functioning properly. The resistance to ground of the grounding system should be measured periodically to verify that it is within acceptable limits. If the resistance to ground is too high, additional supplementary grounding electrodes may be required. Understanding the requirements for supplementary grounding electrodes is essential for ensuring the safety of electrical systems. By following the NEC and local electrical codes, and by consulting with a qualified electrician, it is possible to design and install a grounding system that will provide effective protection against electrical shock. The role of the water utility company in grounding systems is primarily related to the use of metal underground water pipes as a grounding electrode. When a metal underground water pipe is used as a grounding electrode, the water utility company is responsible for ensuring that the pipe is properly installed and maintained. This includes ensuring that the pipe is in direct contact with the earth for at least 10 feet and that the pipe is not damaged or corroded. The water utility company may also be responsible for providing information about the pipe to the electrical contractor or inspector. This information may include the type of metal the pipe is made of, the length of the pipe, and the location of the pipe. In some cases, the water utility company may require that the electrical contractor install a bonding jumper between the water pipe and the grounding electrode system. This bonding jumper helps to ensure that the water pipe is at the same potential as the other grounding electrodes, which can help to reduce the risk of electrical shock. It is important to note that the water utility company is not responsible for the design or installation of the electrical system. The electrical contractor is responsible for ensuring that the electrical system is properly designed and installed in accordance with the NEC and local electrical codes. However, the water utility company does play an important role in ensuring that metal underground water pipes are properly used as grounding electrodes. Understanding the roles and responsibilities of both the electrical contractor and the water utility company is essential for ensuring the safety of electrical systems. The statement from the water utility company should confirm that the water pipe is made of copper. The reason for this requirement is that copper is a good conductor of electricity. This is important because the water pipe is being used as a grounding electrode. A grounding electrode is a conductor that is used to connect the electrical system to the earth. This connection provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. If the water pipe is not made of copper, it may not be a good conductor of electricity. This could increase the risk of electrical shock. The statement from the water utility company should also confirm that the water pipe is continuously buried for at least 10 feet. The reason for this requirement is that the water pipe needs to be in contact with the earth in order to function as a grounding electrode. The earth is a good conductor of electricity. This is because the earth contains a lot of moisture and minerals. The moisture and minerals help to conduct electricity. If the water pipe is not in contact with the earth, it will not be able to function as a grounding electrode. This could increase the risk of electrical shock. The water utility company can typically provide documentation that confirms these details about the water pipe. It is important to obtain this documentation from the water utility company in order to ensure that the grounding system is installed correctly and safely. The resistance between the water pipe and the grounding electrode system should be measured with a ground resistance meter. A ground resistance meter is an instrument that is used to measure the resistance of the earth. This measurement can be used to determine whether the grounding system is effective. To measure the resistance between the water pipe and the grounding electrode system, connect one lead of the ground resistance meter to the water pipe and the other lead to the grounding electrode system. Then apply a test current to the circuit and measure the voltage drop. The resistance is calculated by dividing the voltage drop by the test current. The resistance between the water pipe and the grounding electrode system should be less than 25 ohms. If the resistance is greater than 25 ohms, the grounding system is not effective and needs to be improved. There are a number of ways to improve the grounding system, such as adding additional grounding electrodes or improving the connection between the water pipe and the grounding electrode system. It is important to consult with a qualified electrician to determine the best way to improve the grounding system. This resistance measurement provides valuable information about the effectiveness of the grounding system. It helps to ensure that the grounding system is functioning properly and that it is providing adequate protection against electrical shock. The inspector might not be satisfied, even with documentation, for several reasons. Firstly, the inspector may have concerns about the reliability of the documentation provided. They may question the accuracy of the water utilities records or the method used to measure the resistance between the water pipe and the grounding electrode system. Secondly, the inspector may have specific local code requirements that are more stringent than the NEC. These local codes may require additional grounding electrodes or a lower resistance to ground than what is specified in the NEC. Thirdly, the inspector may have concerns about the soil conditions in the area. If the soil is particularly dry or rocky, it may not provide a good connection to ground, even if the water pipe is properly installed and the resistance to ground is within acceptable limits. Fourthly, the inspector may have a general concern about the safety of the electrical system. They may feel that the existing grounding system is not adequate to protect against electrical shock, even if it meets the minimum code requirements. If the inspector is not satisfied with the documentation provided, it may be necessary to install an additional supplementary grounding electrode. This will help to ensure that the grounding system is adequate and that it meets the inspector's requirements. It is important to work with a qualified electrician to determine the best way to improve the grounding system and to satisfy the inspector's concerns. The need for an additional supplementary grounding electrode would depend on several factors. These factors include the inspector's interpretation of the code, the local soil conditions, and the overall effectiveness of the existing grounding system. Firstly, the inspector's interpretation of the code plays a significant role. While the NEC provides general guidelines, local jurisdictions may have their own amendments or interpretations that are more stringent. If the inspector believes that the existing grounding system does not meet these local requirements, they may require an additional electrode. Secondly, the soil conditions in the area can also affect the need for an additional electrode. If the soil is particularly dry, rocky, or sandy, it may not provide a good connection to ground. In these cases, an additional electrode may be necessary to lower the overall resistance to ground and ensure that fault currents can flow safely back to the source. Thirdly, the overall effectiveness of the existing grounding system is an important consideration. Even if the water pipe meets the requirements of section 250.52 and the resistance to ground is within acceptable limits, the inspector may still require an additional electrode if they have concerns about the system's ability to handle fault currents effectively. In summary, the decision to install an additional supplementary grounding electrode should be made in consultation with a qualified electrician and should take into account the inspector's interpretation of the code, the local soil conditions, and the overall effectiveness of the existing grounding system. In a given situation, it is argued that the installation is correct and the inspector's violation is incorrect. The basis for this argument is the NEC, specifically section 250.54, which states that if the primary grounding electrode is an underground water pipe, the resistance requirements for the supplementary grounding electrode do not apply. This means that the inspector's requirement for a 25 ohms or less resistance test on the ground rod is not applicable in this case, as the underground water pipe serves as the primary grounding electrode. However, it is crucial to provide the inspector with documentation that the underground water pipe meets the requirements of section 250.52. This documentation can include a statement from the water utility confirming that the pipe is copper and is continuously buried for at least 10 feet, as well as measurements of the resistance between the water pipe and the grounding electrode system. By providing this documentation, it can be demonstrated that the installation complies with the code and that the inspector's violation is not justified. However, it is important to be aware that the inspector may still have concerns or require additional information. In these cases, it is important to communicate effectively with the inspector and to address their concerns in a professional and respectful manner. If necessary, it may be helpful to consult with a qualified electrical engineer or code expert to provide additional clarification or support. It is also important to consider that local codes or interpretations may vary, and it is always best to comply with the local requirements, even if they seem to contradict the NEC. In some cases, it may be necessary to install an additional supplementary grounding electrode to satisfy the inspector's concerns, even if it is not strictly required by the NEC. The phrase, in summary, "your installation is correct and the inspector's violation is incorrect," means that based on the information provided in the relevant sections of the NEC, the electrical installation appears to be in compliance with the code, and the inspector's rejection of the installation is not justified. However, it is important to note that this is just an opinion based on the information available. Final decision on whether the installation is acceptable rests with the electrical inspector. It is important to work with the inspector to resolve any concerns they may have and to ensure that the installation meets all applicable codes and regulations. This can be done by providing the inspector with documentation that the installation complies with the code, such as a statement from the water utility confirming that the water pipe is copper and is continuously buried for at least 10 feet, as well as measurements of the resistance between the water pipe and the grounding electrode system. If the inspector is still not satisfied, it may be necessary to install an additional supplementary grounding electrode. However, this should not be necessary if the installation complies with the code and the inspector's concerns are addressed. In the context of the NEC, documentation refers to any information that can be used to verify that an electrical installation complies with the code. This documentation can take many forms, including written statements, measurements, and photographs. Some examples of documentation that may be required for a grounding electrode system include, firstly, a statement from the water utility confirming that the water pipe is copper and is continuously buried for at least 10 feet. Secondly, measurements of the resistance between the water pipe and the grounding electrode system. Thirdly, photographs of the grounding electrode system showing that it is properly installed. Fourthly, a copy of the electrical permit for the installation. Fifthly, a copy of the electrical inspection report for the installation. The specific documentation that is required will vary depending on the type of installation and the local codes and regulations. It is important to consult with the local electrical inspector to determine what documentation is required for a particular installation. The purpose of documentation is to provide evidence that the electrical installation has been done correctly and that it meets all applicable safety standards. This helps to protect people from electrical shock and to prevent fires. Documentation is also important for liability reasons. If there is an electrical problem that causes damage or injury, the documentation can be used to show that the electrical installation was done correctly and that the contractor is not liable. The electrical inspector may require additional supplementary grounding electrode even if the primary grounding electrode is an underground water pipe that meets the requirements of section 250.52 in certain situations. These situations may include, firstly, local code requirements that are more stringent than the NEC. Some local jurisdictions may have adopted amendments to the NEC that require additional grounding electrodes in certain situations, such as for large buildings or for buildings with sensitive electronic equipment. Secondly, soil conditions that are not conducive to effective grounding. If the soil in the area is particularly dry, rocky, or sandy, it may not provide a good connection to ground, even if the water pipe is properly installed. In these cases, the inspector may require an additional grounding electrode to lower the overall resistance to ground. Thirdly, concerns about the reliability of the water pipe as a grounding electrode. Water pipes can corrode or become damaged over time, which can reduce their effectiveness as a grounding electrode. If the inspector has concerns about the condition of the water pipe, they may require an additional grounding electrode to provide a more reliable grounding path. Fourthly, the presence of sensitive electronic equipment in the building. Sensitive electronic equipment can be damaged by electrical surges or noise. An additional grounding electrode can help to protect this equipment by providing a low impedance path for these surges or noise to ground. Fifthly, the size of the electrical service. For large electrical services, the inspector may require an additional grounding electrode to ensure that the grounding system is adequate to handle the potential fault currents. The phrase, however, based on the code requirements, this should not be necessary indicates that according to the NEC, specifically section 250.54, the supplementary grounding electrode, in this case, the ground rod, does not need to meet a specific resistance requirement of 25 ohms or less if the primary grounding electrode is a metal underground water pipe that meets the requirements of section 250.52. This is because the water pipe is considered to be a sufficiently effective grounding electrode on its own. However, the phrase also implies that the inspector's requirement for the ground rod to meet the 25 ohms resistance is not in line with the NEC. Therefore, the implication is that installing an additional supplementary grounding electrode solely to satisfy the inspector's incorrect interpretation of the code should not be necessary. The phrase is meant to reassure that the installation is likely compliant with the NEC, and the focus should be on providing documentation to the inspector to demonstrate this compliance. The phrase in summary, "Your installation is correct," and the inspector's violation is incorrect suggests that based on the understanding and application of the relevant sections of the NEC, the electrical installation meets the code requirements, and the inspector's rejection or citation of a violation is not justified. This conclusion is drawn from the fact that the primary grounding electrode is a metal underground water pipe that meets the criteria outlined in section 250.52, and the supplementary grounding electrode, the ground rod, is not required to meet a specific resistance value when a qualifying water pipe is used as the primary electrode, as per section 250.54. The phrase also implies that the person should confidently present their case to the inspector armed with the relevant code sections and documentation to demonstrate compliance and hopefully resolve the issue. However, it is important to maintain a professional and respectful demeanor when communicating with the inspector and to be open to further discussion or clarification if needed. The phrase "you should provide the inspector with the necessary documentation to prove that your installation complies with the code" means that the responsibility lies with the electrical contractor or installer to demonstrate that the electrical installation meets the requirements of the NEC and any applicable local codes. This is typically done by providing the inspector with documentation such as permits, plans, specifications, and test results. In this specific case, the documentation should include evidence that the underground water pipe meets the requirements of section 250.52, such as a statement from the water utility confirming that the pipe is copper and is continuously buried for at least 10 feet. Additionally, it may be helpful to provide the inspector with a copy of section 250.54 of the NEC, which clarifies that the supplementary grounding electrode does not need to meet a specific resistance value when a qualifying water pipe is used as the primary electrode. By providing this documentation, the electrical contractor can help the inspector understand that the installation is code compliant and that the violation is not justified. It is important to maintain a professional and respectful demeanor when communicating with the inspector and to be open to further discussion or clarification if needed. The phrase "Lockport IL" indicates the general geographical area where the electrical installation took place. While precise GPS coordinates are not directly relevant to the technical aspects of grounding and code compliance, the location can indirectly influence factors such as soil conditions and local code amendments. Firstly, soil conditions can vary significantly depending on the location. The type of soil, its moisture content, and its mineral composition can all affect its conductivity and therefore the effectiveness of grounding electrodes. For example, sandy or rocky soils tend to have higher resistance than clay soils. The soil conditions in Lockport, IL may be relevant to the inspector's concerns about the grounding system and whether or not an additional electrode is needed. Secondly, local code amendments can also vary depending on the location. Some jurisdictions may have adopted amendments to the NEC that are more stringent than the national code. These amendments may require additional grounding electrodes or other measures to ensure the safety of electrical systems. The local code requirements in Lockport, IL may be relevant to the inspector's violation and whether or not the installation is compliant. Thirdly, environmental factors such as temperature and precipitation can also affect the performance of grounding systems. In areas with cold winters, the ground can freeze, which can increase its resistance. In areas with high rainfall, the ground can become saturated, which can decrease its resistance. The environmental conditions in Lockport, IL may be relevant to the inspector's concerns about the grounding system.